Hello and welcome to Dr. Anima Upadhyay's Chemistry and Technology lecture videos. Under nanomaterials, today we will study a new topic, that is graphene, which is a very thin transparent layer of graphite. But before I start today's video, I would like you to please subscribe to my channel if you have not done it so far, and to also share this video among all your friends and colleagues. So let's begin with today's topic, that is graphene. What is graphene? Graphene is one atomic thin transparent layer of graphite with sp2 bonded carbon atoms. These carbon atoms are arranged in a hexagonal or honeycomb lattice. It is the thinnest material on earth and it is 1 million times thinner than a human hair. Of course, it is a well-known nanomaterial. To understand how the graphene layer looks like, I have given you the image of a layer of graphene. Are graphene and graphite structurally same? No. Graphite is three-dimensional structure, whereas graphene is a two-dimensional structure. So there is a slight difference in the structural makeup of graphene and graphite and also in their fabrication methods. What is graphite? When many layers, hundreds of thousands of graphene are stacked one above the other, it forms graphite. Graphite is a naturally occurring mineral in a metamorphic rock and is one among the three naturally occurring allotropes of carbon. What are the other two naturally occurring allotropes of carbon? It is diamond and amorphous carbon, which also occur naturally in the nature. What is the difference between the three allotropes of carbon? It is the difference in the structure and bonding of the atoms within the allotropes. Diamond has a crystalline lattice structure, graphite has a honeycomb lattice, and carbon is amorphous in nature. What is graphene made from? Graphene is made up of pure carbon and it is extracted from graphite. As you can see in the figure, where I have shown you that how the graphene is getting extracted from graphite. How is graphene obtained from graphite? Graphene is produced by sonication, that is by dispersing graphite in a proper liquid medium, a process which is known as liquid phase exfoliation process. Discuss the properties of graphene. Graphene is tough, flexible, lightweight with a high resistance. It is 200 times more resistant than steel and 5 times lighter than aluminium. It has unique physico-chemical properties like high surface area, good biocompatibility, strong mechanical strength, excellent thermal conductivity, ease of functionalization, and fast electron transportation. The semiconducting properties of graphene are better than silicon, and it is the future of quantum computing technologies. Discuss the electronic properties of graphene. Graphene gives easy movement of electrons without scattering because it has a delocalized pi electron system across the surface, enabling fluid-like or free movement of electrons. Graphene system has no band gap due to the overlapped pi electrons, thus allowing for an easy movement of electrons without the need of external energy into the system. Thus, graphene has high electronic mobility and the electrons acting like photons with respect to their movement capabilities. How graphene rivals silicon in its semiconducting properties? Graphene rivals silicon and can replace it in future because it is more efficient due to its superior speed and energy efficiency compared to silicon. It requires less energy to switch on and switch off. It allows electrons to flow without creating unwanted heat that is needed to be cooled down later. This would help in running the phones for weeks without recharging, thereby reducing energy consumption, pollution, and fossil fuels consumption. Graphene semiconductors will also help in overcoming challenges in the development of quantum computing technologies. What properties of graphene are useful in its electronics applications? High conductivity, lightweight, transparency, flexibility and high resistance are important properties which makes graphene very useful as a semiconducting material. High conductivity and lightness of graphene is useful in which technological applications? High conductivity will increase the useful life of batteries by 10 times and lightness will be suitable for manufacturing batteries for drones. What are the thermal properties of graphene? The repeating structure of graphene makes it an ideal thermal material to conduct heat in a plane. It can exhibit two types of thermal conductivities, in-plane and interplane thermal conductivities. To boost its interplane thermal conductivity, other nanomaterials such as carbon nanotubes are added. The structure allows the movement of phonons throughout the material without obstruction. What are the mechanical properties of graphene? Mechanical strength of graphene is unmatched and can significantly enhance the strength in many composite materials, very useful in fabricating the structures. Discuss the elasticity and flexibility in graphene. This is a very desirable property as not many molecules can be flexible and supportive at the same time. Whereas graphene is both flexible and supportive simultaneously. The repeating sp2 hybridized backbone of graphene allows for flexibility, enabling the rotation around the bonds, still providing with enough rigidity and stability that the molecule can withstand changes in conformation and support other ions also. What are the applications of graphene as sensors? Graphene has innumerous applications as sensors. It can detect minute changes in surrounding environment due to the planar and consistent arrangement of atoms in the graphene sheet. Every atom in the sheet is exposed to the environment equally. This allows graphene to effectively detect the changes in its surroundings, providing a high degree of sensitivity. Sensors employed in various fields includes biosensors, diagnostics, field effect transistors, DNA sensors and gas sensors. What are the applications of graphene in batteries? Graphene can be incorporated both as anode as well as cathode to increase the efficiency of the battery and to improve the charge and discharge cycle rate. The excellent electrical conductivity, surface area and dispersibility of graphene enhances the beneficial properties of traditional inorganic based electrodes, simultaneously relieving the electrodes of their limitations. Due to its versatile nature, it has been incorporated in supercapacitors, fuel cells, lithium-ion and lithium-sulfur batteries. How graphene is useful in electron emission display? It is an ideal material for use in electron emission displays as it exhibits a high aspect ratio and the dangling bonds at either end of the sheet, allowing for efficient electron tunneling. The graphene surface provides linear dispersity to produce massless direct fermions. When exposed to an electric field, the field emission liberated electrons avoid all backscattering because their escape velocity is independent to their energy. Direct fermion is a spin half particle. What are the applications of graphene as composites? Graphene is being incorporated into many materials to make the existing material stronger and lightweight. And this application is very useful in aviation industry where graphene incorporated composite material is much lighter than steel, still providing better strength and also helps on savings on fuel consumption. Incorporation of graphene into polymers forms graphene polymer composite materials. It helps to increase the tensile strength, shelf life and electrical conductivity properties of the polymeric materials. Thus, incorporation of graphene in composite materials is very effective. What are catalytic applications of graphene? Graphene is inert and does not interfere or interact with the catalyst and the substrate. Thus, it provides an even dispersion of catalyst particles, so the catalyst substrate reaction is consistent across the whole support. Does graphene sheets finds applications in nanotechnology? Yes, it finds many applications as carbon nanotubes, fullerenes, nanoribbons, quantum dots, graphene ink, etc. What are the types of graphene? There are many types of graphene such as graphene oxide, graphene nanoplatelets, graphene nanoribbons, graphene quantum dots and graphene ink or graphene master batches. Is graphene transparent? Yes. Graphene is a two-dimensional nanomaterial with more than 97% optical transparency. What are the methods for the synthesis of graphene? There are three ways: chemical vapor deposition, chemical or plasma exfoliation from natural graphite and mechanical cleavage from natural graphite. How graphene be used in making fullerenes, carbon nanotubes and graphite? Graphene, when wrapped, it forms fullerenes. When scrolled, it forms carbon nanotubes. And when it is stacked one above the other, it forms graphite. What is green graphene? The graphene which is obtained by the recycling of the materials causing least damage to the environment are called green graphene. Are graphene face masks and facial masks good to use? Yes, graphene nanoplatelet and graphene oxide face mask materials inhibits infectivity. It is hypoallergenic. It is soft and does not irritate the skin, and it is comfortable to wear. Why is graphene the future material? Graphene is known as the material of the future because of its applications in different sectors. It's a material with great potential in a wide range of many diverse processes, from the manufacture of smartphones to the construction of solar panels, in bulletproof materials, in aerospace, in semiconductors, batteries, in medical field and in environment. What material will replace graphene? Graphene will replace graphene in future. How is graphene similar to graphene? Graphene is similar to graphene as both have two-dimensional structure of carbon. What is the difference between graphene and graphene? Unlike graphene, graphenes contain double and triple bonds and its atoms do not always have a hexagonal arrangement. So here we come to an end of this video. If you have any further queries, please leave your question in the comment box. I will definitely give the answer back to you. Please keep watching my videos. The other videos on nanotechnology and nanomaterials which I have already uploaded, I will give the link in the description box. Thank you for watching till end.